2 o'clock, so let's go ahead and start recording. So, okay, today we are going to get you set up. So, this first week has been primarily setup, getting you both set up and with programming and getting you familiarized with programming. That's what we're doing in your labs. Yes, you do have labs on Friday and Monday. You have labs this week. They are in person. Your first lab assignment is the canonical first thing you do when you're learning programming, which is a variation of Hello World. Now, a Hello World program, what that is just simply getting the computer to print out Hello World. In your lab, however, rather than doing Hello World, we're going to have you print out the biography of a famous computer scientist. You get to choose so long as their last name isn't Gates, Jobs, or Turing. So, it's because otherwise, I get a lot of students who would do that. Ada Lovelace is a good idea, Grace Hopper, but I'd also just simply Google famous computer scientist and pick somebody who looks interesting to you in terms of like their accomplishments. There's quite a few of them. But you'll get set up for programming and how to install Python in your lab. Now, for those of you who for some reason if for some reason you cannot make it to your lab, or you're watching this recording because you are sick at home right now, or your TA, or you miss what your TA says during the lab, or you come in late to lab, not to worry. I don't want you to fall behind. Click on modules, and you'll be able to find a ton of stuff here. We're in module 1 right now, and you're going to be working on lab 1. And what you'll want to do is you'll want to click on installing Python. That video will go over how to install Python. If you are working on a Chromebook or a tablet or something, best come and speak with me to figure out that stuff. The CS50 IDE that I show off in this video has been it's not that it no longer exists. It's just been replaced by a different tool that they link to. So there's still web-based tools out there, but it may not be but it may be more industrial strength than you need. When you download and install Python, and I go over this in the installation video, you get if you're using a Mac or a Windows, and you go through these instructions the way I show you. In that case, that will install something called IDLE onto your computer. IDLE, named after Eric Idle. There's a lot of Python is named after the Monty Python TV show, or and comedy groups and comedy skits and stuff like that. So Eric Idle, one of the inventors. So a lot of stuff is taken from that comedy. So but IDLE is the programming tool and editor that comes pre-installed. And I use that in this class simply because it becomes pre-installed with Python, and it's very, very minimalistic. Okay? Very, very minimalistic. Now, as I mentioned this, I'm pretty sure, in a lot of the videos that I do to startup, and I mentioned this to the TAs to be sure so that they know to look out for this, but I'm going to go ahead and mention this to you here. The most common mistake I see, like as you're just getting started up, is that when you type IDLE or you open up IDLE, you get this. This is what we call a Python interpreter. There are two types of programming languages, and Python is the interpreted type of language. The other type of language is compiled, where basically you take a block of code, where you take a program, and it gets translated from a programming language into the instructions for the computer all in one go. Instead, this is an interpreted language, where rather than translating an entire program, it takes it one line at a time, essentially. The advantage of this is that while it's slower than compiled languages, it ends up being a lot more flexible in the syntax and grammar. In other words, it's easier to program in, and you can be a lot more verbose. So as a result, you can just kind of do one line at a time. So when I open up this is opening up into what's called a REPL, R-E-P-L. Read, evaluate, print. A read, evaluate, print loop. It does one thing. It just basically keeps asking you for commands. Here, if I simply say, and if I give it some commands like print, hello, it will execute that command and do it. And a lot of people try to do their programs in here in the REPL. That's not what you want to do. Instead, what you want to do to write a Python program, think of this as either the output or the testing window. This is where you're going to get your, where the output of your program is going to be, and this is also where you can test like a couple of lines of code to debug something or test something before you type it in, might be. To write a script, to write a program, you hit new file, and then you come up with this empty thing, and that's where you do your typing. So think of this as input window, output window. It's a script, and your interpreter will translate it line by line, just like an interpreter at the UN will kind of translate sentence by sentence when they're translating a speech from one thing to another. So here, if I go print hello, it will prompt me to save it, which I'll do on my desktop. And again, this is what you'll be doing in your lab. I'm just going over this to make sure that that as few people get affected by this very common mistake as possible. And then I've saved it, and then to run the program, it may be hard to see because of the way the UI is here, but it says run over here, and you just simply hit the run and click run module. It says hello. I typically just simply use F5 to run it, and that will do that for me a lot of the time. So, there, hello, there we go. So anyway, but that's what you'll be doing in your lab, getting set up so you can use this, installing Python there. We don't need to install Python on your computer today. What we do need to do is make sure you're set up for a Runestone account if you haven't already done so. So that's our first task for today, because we'll be doing a project from the textbook today. This will, nothing to worry about. Again, the in-class exercises are things where you're expected to be able to finish them and do them, and I'm going to give you the answers as we go along, right? So first things first, let's go ahead and go to Canvas. And to get to Runestone, either go to Canvas and go and click on Required Course Materials and hit the Click Here button, or just simply go to runestone.academy.com. Sorry, or no, not even .com, runestone.academy. Runestone.academy, and that's it. You'll get there. Or you can Google Runestone Academy, and it will pull it up. And as long as you get here, that's great. Once you're here, either click register and get started or log in, right? So if you click log in and you don't have an account, no problem. Just hit the let's see. Yep. If you click the login, click sign up over here to start making an account or register and get started. Again, if you clicked on that link, click on this sign up page over here. Either way, if you go through the login to get here, or you click on the sign up, you'll get to this page over here. So get to this page if you haven't made an account already, okay? And then over here, we'll be able to create our account. Put in whatever username you want. I'll be able to see that username and see who that user is. So, use some judgment, I guess, for what you use as your username. When in doubt, just use initial last name. Put in your first name and last name, preferably as they appear on Canvas. If you've got a middle initial that's not and it's not asking for one, don't worry about it. As long as I get your first name and last name correct, or I get the TU email address correct, it'll be fine. So for me, I might do A.B. Rosen, Andrew Benjamin Rosen. I do Andrew Rosen. My email, so I'm going to use my TU email address, not my alias, TUG85861, that at temple.edu. And that's my address, that basically if you send an email to andrew.rosen, that's where that translates to. Password, you'll want to create a password. Okay, I'm going to call it 1234. Obviously, you can't do 12345. You'll want something a bit more there. The main thing that you need is the course name, and that will be Spring 2024 Rosen, right? And only go through this process if you haven't done it, if you haven't signed up for an account yet. If you have signed up for an account, just log in. Okay. Spring 2024 Rosen, click the agreement, and there's no need to create the course. The course is already created. And again, making your own course is not going to be as useful as you think, because it's not going to give you the answers unless you already know Python, in which case you don't need the answers. So it's kind of a catch-22 there. So anyway, so once you've signed up and you've signed up for that appropriate class, let me log in. Log in. You'll either be taken to the course directly, or you'll land on a page like this that says course selection. If it doesn't already automatically bring you here, just then select Spring 2024 Rosen from whatever selection you have. So just has everybody been able to get to this page at this point? Does anybody still need more time? No? Okay. So there's a couple ways to get to the textbook proper, because what it will do is that list me, it's going to list the textbook, and then it lists the assignments, in reverse order of when they're due. But if you click on back to textbook or this link over here, it's going to bring us to the actual textbook itself. So click on that, and we are going to scroll almost all the way down the page to Project 1, a preview of the end goal. And so you want to go there and click on a preview of the end goal, which coincidentally, by the way, if you have already signed up for this course, can also be found by going to Canvas, going to Modules, and I try to do this for each of the in-class exercises we do. I fixed the link from yesterday. I updated this link. You can click on this, and it will bring you directly to that same page. So I try to put this in the overview. By the way, also over here, if you've got extra time this weekend and want to try some other stuff, there's more detail here from this comic about Ada Lovelace. And then over here is a, let's see, yes, I think this was an embedded playlist at some point, but there's a Crash Course Computer Science playlist where they go over not necessarily programming, but the concepts of programming and some of the theory behind it. And the way it's a very useful playlist, no matter what language, because it goes over a lot of high-level concepts that you'll learn throughout your curriculum here. So, all right. So once you've got into a preview of the end goal, again, by either going here and going to the textbook and scrolling all the way down to the appendix and clicking this one, or going to Canvas and clicking Module 1 going to Modules, clicking Module 1 Overview, and then clicking a preview end goal. We are now on the project page. Most of the time, this will be a lot quicker, because you'll just simply either go to Runestone or you'll just click on the link from Canvas and you'll be there. Okay, but again, this first lecture is all about getting set up. So the author says that computer programming can be one of the most rewarding experiences ever. I tend to agree. It can be very rewarding to do it. You get to make things, and it feels good when you make those things. You can do a lot. It says from understanding human speech to image processing to computer-generated animation, you can do almost anything with code. But we have to develop our skills first. You're not expected to sit down at a piano when you're just learning piano and spit out one of Beethoven's piano sonatas, right? Just like for those of you who have played a musical instrument, or have learned to play a musical instrument, or are currently in marching band, well, marching band's not in season, concert band, or pep band or the like, you know that playing a musical instrument requires practice. And so does this. It's practice. And that's unfortunately why I say it's going to take 8 to 12 hours. Even if you're quick and clever, that's only going to get you so far in the class, because you got to be able to put in the time to develop the skills. So the idea here is that we want to give you an idea of the things that we can accomplish by the end of the semester. The main thing, and what we want to show you is that computer code isn't, learning to read a programming language isn't as bad as learning a foreign language like Japanese or German or Mandarin or Italian, right? Because it's in English. It's just a really weird instructional English. So I want you to like be able to see these and see that these aren't necessarily as scary as we think, and we'll be able to learn these things. The main thing you gotta remember when working with computers is that computers are just bits of rock we hit with lightning until we trick them into thinking. Okay, they aren't intelligent. It's best to, and if you need to anthropomorphize your computer, it is best to anthropomorphize it as an evil genie. It will do exactly what you say, not what you mean. And that can be very frustrating because that means like a little typo can throw off your entire thing. Humans are amazingly good at overlooking, what's right in front of them if they think it means something else. It's just the way our brains are wired visually. So let's take a look at this at this Python program over here. That's a good example of what we'll be doing, of what we could do at the end of the semester. Okay. You may be able to look it out, but I'm going to walk through it. It's an example of something we can do at the end of the end of the course. All right, and we can see as it's working through what it's going to do. It takes this and it works with this image, but this is called process 11, and this is the way a code block looks in our book. To run it, we hit save and run. Okay, and so let's go ahead and just kind of take this line by line and kind of give you like a brief introduction. I don't expect you to be able to understand all this means. I'm just trying to say this isn't as scary as you may worry it is. Import image. So what does import image do? The import statement says, hey, we want to load up some libraries. That's what an import statement says. Not every program needs like all of Python that's all available to it. So in order to keep your program small, it only loads up what you need when you say you need it. So importing image says, hey, I'd like to work with some like images. So load up the things that make it easy to work with images. So def, process 11. Def is short for define function. Process 11, and so we are doing something called define process 11, and then it's got img. Defining functions. The best way I can say this is that programming languages are different than other languages that in that it's very easy to define new terms in your programming language, right? You can make up words all you want. Getting other people to accept what they are is a challenge, right? Vocabulary changes all the time, right? But with Python and other programming languages, it's very easy. Think of creating a function as adding a new verb to the Python programming language. We're creating a verb called process 11, and when we do process 11, it's going to do something. What? It's going to do what executed down here. So now we hit what's called, so now we have a colon, which is, again, that's part of the grammar of how this works, and we'll learn about that. And then we get this statement in orange. Most editors do what's called syntax highlighting, which is that it takes different part of your programming language's grammar and turns it into different colors. It's a bit weird to think about, but it's useful as a visual aid sometimes, especially with comments. Comments start with a hashtag or a pound sign or a number sign, depending on what you were taught in school. And basically it says, this is, if a computer sees this, it goes, that's human-only text. So this text is only meant for humans to read. It's not code. I'm going to ignore it. And that's what we use comments for. We use them to write comments to other humans. Get the height and width of the image. So IMG is short for image. We get the width and the height of the image. In other words, how big and, how tall and how wide it is. Fairly straightforward. 4 row in range height, 4 column in range width. So, right, so this talks a bit about how pictures work on your computer. And if you get really close to your computers, and this gets harder and harder by every year because those MacBooks really amp up the pixel count. your images are actually divided into tiny, tiny, tiny little squares. You can still see it on the 1080p screens when you get really in, and they're very tiny on those new Macs, but they're tiny, tiny, tiny little squares. Those are what we call pixels or picture elements. And the way a computer draws an image is that each of those pixels has a bunch of some subpixels in it. A red light, a blue light, and a green light. And it just simply shines those at different values, at different intensities, to produce a color. It mixes, rather than mixing color with ink, it mixes color with light, which is actually a bit different, as you will find out. It kind of works counterintuitively, right? Because if you add green and yellow, you mix blue and yellow, that makes green if you're working with like markers and crayons and stuff. Not so with light. Light kind of goes in the other direction. So anyway, but it's made up of pixels. Now, if you worked with matrices at any point, think of it as basically the way it's arranged kind of in internal logic is a matrix. We have pixels with rows and columns. We have an image with rows and columns of pixels. So we have rows, we have columns, and basically these are what we call for loops. These are ways to iterate through and go through each of these pixels rather than having to write out how many pixels there are and how many pixels they are and work through them each one at a time manually. This is a for loop that says automatically give me the number there are and we'll go through them. So this is indented because of the way Python works is that when it's indented, it's part of something. We will go into that in more detail. That's more kind of week 3 stuff. So we get a pixel, and then we ask for the red value, blue value, and green value of a pixel, right? Those, again, we talked about having to mix light together. And we say, hey, if we add those up, divide by 3, and it's bigger than 255, which is a magic number for right now, then set all the values to 255, otherwise set them all to 0. And instead, we'll make a new pixel with those color values, and we're going to change the pixel. So when we run the code, what it does is that it's going left to right and going through each of the pixels. And what it's doing is that it's checking the average of the red, green, and blue value. That's why it's adding them and dividing by 3. It's getting an average. Now, color, at least the way that it's classically taught, colors are made up of red, green, and blue, and each of those red, green, and blues has an intensity from 0 to 255. Why binary? We'll get into that in more detail. Just accept that it's 255 right now. It's to the 8th power. Okay? And it's saying if it's bigger than halfway to 255, then we're going to set the values to 255, which is white. Otherwise, we'll set them to zeros, which is blacks. So in other words, if it's a bright pixel, we'll set it to brightness all the way up. If it's a dark pixel, we're going to turn the brightness all the way down. So hence, this is a literal black and white image as opposed to a grayscale image. Grayscale meaning, and that's what, with grayscale, if you've ever seen old TV shows or, then that's what you get. It's not black and white, they're grays. There's a lot of lights and darks, just shades of gray. Okay, imagine watching a movie made out of that. That would be highly stylized. All right, and if you're interested, that entire process is written over there. Okay, and I mean, the other thing, so we figured that what it did kind of by reading through it. But you can also figure out what something does in a computer just by running the code. This is sometimes inadvisable, but for today, that's a very good way to figure this out, to figure out what we're doing. So now, first thing we want to do here, by the way, just simply to get credit, just because of the way that this is set up on Runestone, over here on Activity Code 2, in order to get full credit, come over here, hit show code, and hit save and run. That's all you need to do. And once that's done, you can hide it again. But what we've got here is that we're going to have 10 separate functions over here. They're all listed here for reference if you want to go through them. Otherwise, they're just going to be hidden from you. But if you want to see them all, you can find them over here. Okay? And you can even download them yourself. And we've got two images over here, yawningsquirrel.jpg and lutherbellpic.jpg. JPEG being one of the primary image formats, such as GIFs or GIFs or PNGs. Primarily it's PNGs, GIFs, and JPEGs. So your first task today is to experiment with these 10 different functions and figure out what they do. There's 10 separate functions. They're called process 1, process 2, process 3, and can you guess the rest of them, the rest of the 10? It's I'm sure you can. We're good at patterns. Okay? And I want you to figure out what they do. Now, obviously, it's a bit much to ask you to go through this code and as complete novices and figure out what all these things do. So instead, in this other code box, activity 3, we have, here's an example that you will modify in order to figure out what the code does. So here it says, original is equal to image.image yawningsquirrel.jpg. Notice that we have a lowercase and an uppercase. I know why this is. Explaining this is not worth it at the time, but what is important to understand is that programming languages in general are what we call case sensitive. That means it cares whether or not things are uppercase or lowercase. Okay? So original is image.image, yawning squirrel.jpg. And this is in between quotation marks, single quotes over here. And that simply represents what we call a string. A string is basically text, and this is letting the computer know this is some kind of text that I should be reading. It's not code. It's text that's going to be used in the code. In this case, it's the name of the file. So this loads up that picture, that yawning squirrel picture that we got. Okay? We take the original, we do process, and then we do process 10 on the original. We have this new verb, process 10, and we take original as the input. So process 10 is the verb. To actually do the action, to do the verb in a programming language, you have to use the function. We have to do what's called invoking the function. And I like that word, invoking. It makes it sound like we're doing magic, which is not great for teaching, but makes me feel important. So we have to use the parentheses to invoke it. And now, part of what we need to invoke a function is that functions just tell you how many parameters they need. In other words, what they need to succeed. And most of these need an image, right? It needs to be provided with an image in order to do something, right? If you have a verb, if you've created a verb, like pick the word like bounce. I bounce what? What are we bouncing? A ball, hopefully. Otherwise, I bounce, that has unfortunate implications if depending on what happened in the preceding sentences, you know. So over here we have original, and we'll just simply give it original. This is, again, the original text we have here. Hit save and run, and if you modify it, remember, we can rewind this code. And so what it does is it takes this, gets the final image, and it runs it on this, and then draws it for us. So that is what process 10 does. Okay? If we want to change this to do a different one, we'll want to do process 1, like that. And we can run on process 1. And we let that run, and it's going to take a bit, and it gave us this image of the yawning squirrel. Remember, this was the original, and this is what's changed over here. So your job is that I've got all these things over here on the left, I've got the processes over here on the left, and the effects over here on the right. And what you want to do is for each of these, and feel free to work together with your people next to you or around you or your friends, you can just drop these in to figure out which is which. There's a nice handy reset button and check me button, and you can check it as many times as you need to over there. So the one thing I will say is that, you know, all you have to do is change the number, the process number, obviously, to get this working, except for process 5 and process 6. Notice over here, process 8, 7, 4, 9, 2, they all take in an image. Process 5 says it takes in a number. So try playing with like 1 or 2 to see what that is. In other words, it needs 2 arguments here. Like process 5 would need like original and 2 or original and 1. So play around to figure out what that does. Similarly, process 6 will need 3 arguments, which are things separated by commas. When in doubt, use this as a pattern, but it doesn't want you to pass in like the word num1, num2. Pass in an actual number. Plug in an actual number instead of the variable name. Okay, so go ahead and have fun with that for about 5-10 minutes. I'm going to go around the classroom helping people who get stuck anywhere. Make sense? And remember, when in doubt, if you accidentally mess stuff up, just simply don't worry. You can always rewind to the original using this bar up here. So over here, pause now. So the main thing here is that a few of these, like 5 and 6, were meant to make you stop and go, wait, I need help. What's going on? So if you couldn't figure that out on your own, don't feel bad. You weren't necessarily supposed to. So let's go through these one at a time and kind of figure these out. So for those of you who were able to finish it, awesome. For those of you who weren't able to finish it, as long as you were trying and kind of figuring out, okay, if I've got a bit more time, I can do this, then that's where I wanted you to be. And if you were completely lost, come up and speak to me after class. And if you weren't completely lost and still want to speak to me, that's fine. So let's go ahead. This one seems to darken the corners a little bit, but I'm not like sold on what I'm going to be selecting yet. So process 2, let's try that one out. Process 2 did what? Oh, that's a weird effect. Okay. Process 3. So process and yeah, that might be the Claridon, darkers and darkers. Okay, 3, that's got to be grayscale. That can't be anything but grayscale. That's grayscale. I don't have these memorized, by the way. The last time I did this was last semester, so I only know 5 and 6 essentially. Process 4. Process 4 is fairly straightforward. But remember, that's fairly straightforward. It rotated 90 degrees. Right, flipped. So rotates by 90 degrees. That's process 4. And process 5, we tested that on 2. Let's go ahead and test that on 3. Save and run. And process, we get our start with our image. And it rotates. And then it rotates again and rotates again. So it started like this. And upside down was 180. And so if we look at this and how it turns, then this was a 270 degree turn. So, and I put in 3. So it rotated 90 degrees 3 times. Process 5. Okay, I'm just zooming out so I can drag appropriately, and I'll zoom back in a second. Process 6, as we're about to see, enlarges the X and Y direction. I know that one. I showed that one to you. That's why I put 2 and 2. So process 6, but nothing is stopping us from putting non-integer values in. Remember, what's an integer right? It's useful to get used to that terminology, especially if you're in computer science. Integers are the numbers that are nice to work with, the ones without the decimal points, and they're the ones that we mostly count with. We don't count with the negatives, but those are integers too. Whereas these are what we call floating point numbers, and they're the ones where things start to get messy, and we don't really like them because it implies that what we're dealing with is about to get messy. Here, we blew it up 150% of the height. So yeah, like I said, that scales the image. So now we'll try process 7. For process 7, that again only takes 1 argument, so we'll remove what we just put in here. Process 7 does what now? That converts it to only blacks and whites. So what do we got? Black, white, red, green, and blue. We don't have black, white, red. It's black and white. It's only black and whites. Certainly not. It didn't just darken it, so it couldn't be that. High contrast, black and white only. So that was 7. Ugh. Okay. Process 8 is what now? Let's see what process 8 does. Ooh, made it a bit brighter. Okay. So process 8 lightened that image. Okay, come on. Process 8 lightened the image. Process 9, is that going to darken the image? Got to be careful with the darkening one though, because there's a few darkening effects, right? I'm happy to say that probably darkens it. Okay. And then 10, the one that I described as mildly demonic, right? So there's the demonic squirrel. We'll see it again. And we've got black and white, but we've also got blue, reds, and greens. And that's fairly, so now that we've, especially since we only have a few left, it's fairly straightforward as to what that one is, right? It may be hard for you to see up here, but let's zoom in just a little bit, okay? Right, the red, whites, and blacks are obviously easy to make out here. If you check out this part over here, you get a bit of green over here, a little green dot over here, and the hard part to see is the eye, that it's got a single blue pixel in it. Single blue pixel in the eye. Okay, so now we've just left with 1 and 2. So we've got the vignette effect and the Clarendon effect. Vignette darkens the corners, and then the Clarendon effect, darks, lights. Got to be process 2. So we go ahead, we hit check me, and it says I'm correct, and that's great. So now, what else do we have? So now, the fun thing about Python and other programming languages is that you can, once you've made these verbs, you can chain them together to do other things. So for example, over here, you can combine the effects of process 1 and process 4 by doing this. You could write it out in a awful looking, so stylistically, there's nothing wrong with writing this. Process 1, open parenthesis. Process 4, open parentheses. Image, close parenthesis, close parenthesis. There's nothing wrong with writing that, except it makes beginning programming students very, very scared. And also, once you go beyond 2 of these, once we start doing 3, it just becomes obnoxious to read. One of the main mantras of coding that takes a bit of appreciation, takes a bit of time to become appreciated, is that code is read a whole lot more than it's written. So it's worth taking the time to make your code easier to write. So rather than doing it all in one line, we'll see this down here split up into multiple lines. So here we load up the original image, and then we perform process 1 on it, and we get step 1. Then we perform process 4 on step 1 and get final. So let's take a moment to talk about that equal sign that we see here, because that equal sign is doing a lot of injustice here, because that you know equal sign for math, and it can get confusing as to what it's doing. That equal sign is what we call the assignment operator in programming languages. What that means is that we have some variable on the left. We have a variable on the left, and unlike in mathematics and physics, we aren't limited to using a single letter, right? And so rather than just using X for everything, we are able to actually put in a descriptive name for our variable names. So on the left is a variable name called original. And the assignment statement, you might better think of it as like an arrow like this, right? And what that says is we're taking the thing on the right and storing it in the variable on the left. So that's what the equal sign does. And we use the equal sign for a few reasons. We could use an arrow, except that says original less than negative image, which could get confusing if we're doing things. And negative, negative, and at this point it just becomes obnoxious with the amount of typing I have to do. So at one point during one of the programming languages, I think it was Algol or Prolog, somebody came up with what we call these days the walrus operator, which, why is it called the walrus operator? Because if you turn it on its side, you see the eyes of the walrus and the tusks of the walrus. That's why it's called the walrus operator. To just distinguish it from the assignment, from the equality sign, and that says, and that's our assignment statement. And because programmers are lazy, once we wrote some new languages, we were like, we don't need the eyes. We can just write an equal sign. So there you go. That's what the equality sign is. It's actually an assignment operation over here. So here we say, let's store our original image. We're going to do process 1 on the original image stored in step 1. Do process 4 on step 1, stored in final. Magic words over here that if I'm going to take a get, which in combination with this says, hey, let's go ahead and make a new window. And then we're going to draw that window. Sorry about the yawning. I don't know why I'm so tired. Oh, right, because I have a kid. That's why I'm tired. All right, so here's process 1, and then it rotates. So you can combine them kind of back to back. Nothing's stopping us from also doing this over here, where I can add in more stuff. Process 1. So here I'm going to take step 1, and then I'm going to take in step 1 over here, and then call this step 2, right? Everybody get why I'm putting step 1 here as opposed to original? Because if I put original, I'd just be repeating what I did in the first place. So step 1, step 2, take step 1, get step 2 from it, take step 2, put step 2 in here to get step 3. Yes, I'm doing the same thing again and again to it, but step 3, step 4, and then I run it again. So let's see what happens. So we should get a dark image. We should darken the corners. Then we should darken the corners. Then we should darken the corners some more. And then rotate, right? So we can kind of chain these effects together. So take like 10 minutes 5 to 10 minutes to experiment with doing this. Now what I'm going to do here is I'm also going to show you another feature of this textbook. I'm going to hit this button over here that says share code. And if you reload your page, if you reload the page, either hit this button over here or depending on your computer and press F5, hopefully you should be able to see in the history for this activity 5 block, okay, my code. Are people able to see it if they reloaded the page? Awesome. And that's one way that as I'm working with this, right, as you go for a solution, right, I'm able to share that code so you don't have to madly scramble down, you don't have to madly type and try to get it before it's gone. I'll just share it with you. I'd rather you focus on the words that I'm saying and not try to madly try to take down everything so you get the full credit and stuff. Make sense? So again, with the answers for this stuff, for the in-class exercises, I want to give you the answers for these. I want to give you the opportunity to work on this. But that's also why it's only worth 5%, because you're getting the answers. Think of it as a participation grade. Okay? So go ahead and work on that, and also once you're done with that, fill out these surveys. I do take a look at them on the post-project questions. And then when we come back, I will go over just a little bit of what we'll be doing with IDLE. Or you can change step 4, you can just change that storage for this kind of thing? Are you trying to? So layer 4 works is that just to kind of start the off. So just kind of memorize this term. Full length in range, parentheses, put here the number of times you might use it. Okay. Times, and then to do it, you need the colon, which says expected indentation. You need that. And then you tab. And that's how Python knows what's inside the horrible. You literally count it inside there. And then also to make sure that it actually processes and updates instead of something the same kind of stuff. That way it keeps updating the same image two times. And then this iterates, yeah. Well, it does iterate through 0 before, it's just not storing the values. That's what it's doing, that's what the underscore says. It says I'm not going to bother using the values. Yeah. And then, so that's, the underscore is literally there as a, I don't care what this is. You know, I'm just here for the loop. I'm not here for what the loop is going over. Yeah. Yeah. It's like this variable doesn't make it too weird. Yep, still running. It may have indicating include code. Maybe you got to go. I don't know. Try and get on the other code. We're going to find out. That probably is what happens. There's a time limit on the code, I think of 30 seconds. So that because it's running in a web browser, if it ran forever, it could potentially lock up your entire web browser. We don't want that because then you have to close the web browser and possibly do a bunch of work. There's a way to modify the, we will learn later ways to modify how long we have to run programs. But in general, you're not going to need more than 30 seconds. Once again, if you are running low on power, right beneath your feet, underneath your seats, there's that black bar that actually has power sockets in it. Okay, yeah, that just means that it took too long. That happens. Don't worry about that. It's probably small. There is. I just don't know it off the top of my head because it's not something by default that we have to worry about. So a couple of common issues that have occurred, by the way. I've seen multiple, not just one person do it. So you don't feel embarrassed, because if I've seen 2 people make this mistake, then that means that there's probably 10 people who've made the mistake. So common mistake I've seen here is to have this step 4, and then you run it and it yells at you that there's no step 4. Sorry, there's no final over here. So it's going to take a minute to get there, I think. Because again, the way Python works is that it goes line by line by line by line. So only when it gets to the line that has an error is it going to yell at you. And there it says line 320, which is not actually 320. There's just a bunch of hidden code. Error name final is not defined on line 8. And what that is saying we're telling, we've got in the previous examples, we had a variable called final. The last step we called it final, and then we told it to draw the final picture. Over here, instead of ending it with final over here, I changed it to step 4. So I never created a final variable. We'll be learning more about this later on, but that's what's going on there. We never created this final variable. So when we did final.draw, we get new win over there. So hopefully you've had the chance to do this. If you haven't, run what you have and fill this out. I want to take a second to talk about variables, since they have come up, and it is what we're going to be covering next week. Okay. It is also what you'll be reading about in your textbook this week. Variables are kind of the first step we have to using Python. But right now, even though you've barely learned anything with Python, as long as you've installed idle, you actually have access to something that's quite powerful in terms of being able to do calculations and stuff for you. So right over here in this shell on the right, I said this is a place for quickly testing code, like a single line of code, or for doing quick calculations, or for getting the output for what I put over here. We can do things like, use it as a calculator, 2 plus 6, okay? 4 divided by 7. And for those of you who are coming from another programming language, you might thought, wait, shouldn't that be 0? If Python tries to do what we call the least surprising option, because that makes it easier for new people to pick up. So 4 divided by 7 works exactly as you'd expect a calculator to do 4 by 7 works. Also, you can do, unlike calculators though, Python can do arbitrarily large numbers. And instead of doing, and now there was another person who asked me this because they went ahead and looked at the code inside. Python does not do, it does not do exponentiation, like 2 squared you would normally write like that, right? You'd normally write 2 squared like that. And for whatever reason, this is the only oddity I think with Python that it has, it does exponentiation by using 2 stars. So 1 star, so here we're saying, 8 times 2, which is 16, and then 2 stars, 8 to the power of 2. Make sense? So that's exponentiation. That's all that is. That's the only thing that's really weird with the operations. But as you can see, you can get very large values without resorting to scientific notation, which is kind of useful for Python. Things get arbitrarily large. So you already have this, but we can also create variables right here. We can do things like x is equal to, 45 plus, times 2. And then we can ask what x is and get that value. So you can store things that, so if you're working in physics or taking physics this semester, you can see where this might be useful. However, what if you mess something up? That's why we have scripts. So you can write it and modify it and run the whole thing at once. So we could say something like, if you're working in physics, if you're working in physics 1, then physics 1 at the beginning is all concerned with something called kinematics, which is the science of motion. So you might want to say you're trying to figure out x, which is, and kinematics is often simply says like, let's see, d is the distance is equal to, this is normally the formula they give you, I think. It's like initial init plus, I think, which is v times t plus, I think it's 1/2. Put that in parentheses, of course, because order of operations is a thing. It works exactly as the order of operations it would be expected to work. So as long as you've learned order of operations in all your other math classes, then you're going to be fine here. 1/2 times a squared, and you just simply can give it the appropriate values over here, right? A is equal to accelerating at 2 seconds per second. Sorry, 2 meters per second. V is equal to, we've got initial velocity of 10. Figure it out for t is equal to 20 seconds, and then we can do init is equal to, our initial position is 5, and then we can then write print d. This is way above what you're going to be doing in, this is more closer to lab 2, except not nearly as messy. Except this is way more messy than lab 2, than what you do for lab 2. And then we can get, we've got an equation that we're able to plug the variables in and test it. And it's also very easy to modify, unlike like on a TI-83 calculator, which is older than me and yet somehow gets still used in schools. Yeah, TI-83 calculators are somehow like inflation proof. Forget the gold standard, go to the TI-83 standard. Those things don't change. So anyway, with regards to that is, so again, experimenting around for like 2 hours with programming on your own can sometimes be extremely beneficial because you can just learn a lot by experimenting. And if you don't, because you don't have time, that's fine. That's why we have class and have the exercises set up for class, and I have specific homework set up to make sure you have those opportunities to work. But that is all I have for today. It is 3:13, so enjoy your 7 extra minutes. If you have anything you want to discuss with me, questions, comments, concerns, complaints, please let me know. I'll be right here, and I've got time until 4 o'clock. I just had to rush out because I noticed something was wrong yesterday. So